Welcome, viewers, to this comprehensive guide that will walk you through some intricate mathematical concepts. Today we'll be delving into the world of percentage errors, vectors, derivatives, and speed. Whether you're a student looking to grasp these concepts for your exams, a researcher aiming to sharpen your analytical skills, or a professional in the fields of mathematics, physics, or engineering, this guide has got you covered. We understand the complexities that these topics can bring, and so we'll break down each one into easily digestible steps. We'll provide clear explanations, detailed walkthroughs, and practical examples to ensure you not only understand these concepts but can apply them confidently in your academic or professional life. So grab your notebooks, pens, and let's embark on this mathematical journey together. Up next, we'll start by understanding how to calculate percentage errors. Stay tuned, and let's unpick these complex concepts one step at a time. Percentage error is a measure of the accuracy of a measurement compared to the true value. To compute the percentage error, follow these steps. Determine the true value or accepted value of the quantity being measured. Measure the quantity using the instrument or method in question. Calculate the absolute error by subtracting the true value from the measured value. Divide the absolute error by the true value and multiply by 100 to obtain the percentage error. Express the result as a percentage. Summation of forces at x. Identify all the forces acting in the horizontal direction, x-axis, and add them algebraically, considering their directions, positive or negative. Summation of forces at y. Repeat the process for forces acting in the vertical direction, y-axis. Once the horizontal and vertical components are determined, use the Pythagorean theorem to find the magnitude of the resultant vector. To find the direction of the resultant vector, use trigonometric functions. Calculate the angle, theta, using the inverse tangent function, arctan, with the ratio of the vertical component to the horizontal component. Express a three-dimensional vector in terms of its components along the x, y, and z axes using the IJK notation. Add or subtract vectors component-wise by adding or subtracting corresponding components along each axis. Calculate the magnitude of a three-dimensional vector using the formula v equals sine sqrt vx squared plus y squared plus vz squared, where vx, vy, and vz are the components along the x, y, and z axes respectively. Output. A derivative represents the rate of change of a function with respect to its variable. For polynomial functions, the derivative of each term is computed separately. Apply the power rule to differentiate each term of the polynomial function. The derivative of a sum of functions is the sum of their derivatives. The derivative of a constant is 0. Speed is the magnitude of velocity representing the rate of motion. Velocity is a vector quantity that includes both magnitude and direction. To calculate speed, divide the distance traveled by the time taken. Position refers to the location of an object relative to a reference point or origin. Acceleration measures the rate of change of velocity. It can be calculated using the formula acceleration equals change in velocity, time interval. Output.